So our next world on Ancient Brain is the genetic algorithm applied to the Traveling Salesman Problem. Now, in contrast to the Finnegan's Wake problem, this is a problem with no known solution in advance. So the problem for the traveling salesman is to find a route through all of these nodes or cities that goes through them all in the shortest path. So we can see here with quite a large number of cities that there are a vast number of routes, and it's found what looks like a pretty good route, but it's still carrying on making some small adjustments to it. So if you gave a human those cities, we can't quite see them now without the line through them, but if you imagine taking away those lines and just looking at those cities here, it's still looking down here for a better route. If you imagine a human trying to map through all those routes, would they have come up with a route as short as this in such a short time? So the top is the best ever route, which is a length of 2565. The bottom shows the best route in each generation, and it also tests new routes in the background. So not absolutely everything it's doing is showing. How many routes has it looked at? It's looked at, slightly hard to see there. It's a 17, is that 100, 200 million, is it? 1, 2, 3, no, 2 million. I think we're up to 2 million. I can't even read that. It's going so fast. So it's gone up to a certain number of routes, but how many routes are there? There are 10 to the power of 44 routes in this city. So the routes it's looking at as a fraction of the possible routes is so small, I can't even map it here, 0.0000. If I reload, I might get a smaller number of cities. That's still 29 cities, 27 cities. Hopefully we'll get a small one. 15 cities. So at 15 cities, there's 14 factorial possible routes, and it's looking at a few 100,000, and it's still pretty small as a fraction of the number of possible routes, but at least it's got off 0. So one thing to say about this is, even though it only looks at a tiny number of the possible routes, it actually comes up with a pretty good route pretty fast. So if I reload until we get a large number of cities, and we'll see how quickly it gets an okay route. So that's quite a few. Oh, there we go. So here we go, about 10 seconds. So within about 10 seconds, it's down to less, probably 5 seconds. It's down to a pretty nice route. That'll do for any business, let's say, that has to travel between those cities. That'll do as a route. So it works it out very quickly, and it never got above 0.0, at least to that number of decimal places, as the fraction of routes that it actually looked at. All right, in the exercise, I have a question for you. So you clone this as usual, you edit it, and here it's got the total number of cities between 5 and 40. But you can change that, change it to between 5 and 400 or whatever you like, but let's make it lower. And if you do actually make it lower, you'll discover that it will actually search all the routes in a fairly short time. The number of possible routes is a factorial, so it's growing very large. But if the number of cities was 5 factorial is not very big. So the question in the exercise is, how small would the number of cities be before, on your computer, it searches all the routes? So it kind of depends on the computer that you have, but on a regular modern PC, how many cities can you reasonably expect within 30 seconds to have a look at every single route? So experiment with that and answer that question. A more challenging edit of the code is to change it to look at random routes each time. Just do a random search and see how well it does. See what routes it's able to come up with. So this one has a route of length 2711, which seems quite good to the visual, doing a visual on it. Your random search, could that get a 2711 in a reasonable time, or would it take all day? So change the code and see what random search will do compared to the GA. The last thing you'll see in the exercise is a suggestion to do exhaustive search. That's exhaustive systematic search. Systematically searching all possible routes. The random search won't do that, and the GA won't do that. So that could be tricky. It's a challenge. You can try that if you like. You can also have some fun with this. I have here a background image, and I have it turned off at the moment. I'm just going to turn it on so you can see, and then you can put in your own background image. So there's a background image. You know already how to upload things to Ancient Brain. Down here it loads up the image, and in the draw function, instead of the background being salmon colored, I'll make it the background image. And there we go. So now it's looking for routes on a map of Ireland. So you can mess around with the background image. You can set it up to be searching 1,000,000 cities. You can speed it up or slow it down with frame rate. Remember from the other worlds that we've done, we have a thing called frame rate in P5. So you can add a frame rate to speed it up. You can change debug information to see how the search is proceeding. So I encourage you to experiment with that, to change these numbers up here, to work in the population size, to change everything that you can reasonably change up here, but in particular to focus on how many routes it's looking at compared to how many routes other methods would be looking at and how well it's doing in what length of time. Okay, hope you have fun with that one.